Hi everyone, and welcome to this tutorial about geometric sequences. Now, if you've seen my video about arithmetic sequences, then you know that it's basically a list of numbers where it increases or decreases by a constant value. So what that means is you either add or subtract the same number. A geometric sequence, however, is one where you have a common ratio. Now, what I mean by that is let's look at a very simple sequence. If I have 2, 4, 8, 16, 32, and so on, to get from one number to the other, all I'm doing is I'm multiplying it by 2 each time. So to get from one number to the other of this sequence, I'm multiplying it by 2 each time. So a sequence where you multiply by a constant value to get from one number to the other is a geometric sequence. So let's look at another example. If I have 100, 50, 25, and so on. Now you might think that it's decreasing, so we're dividing, but remember in a geometric sequence we always multiply. So here the common ratio would actually be 1/2. So I'm multiplying each term by a half, and this would hence be the common ratio. So this is the very basics of a geometric sequence. Now what if I have this same sequence, but I wanted to find out what my 25th term would be. So what is the 25th term? This is the first term, this is the second, this is the third. So what would be the value of the 25th term? Now to actually write each one out, that's a very strenuous job. So to avoid all that, we have a formula, and that formula says u sub n equals, now u sub n is the value of the nth term, where n stands for the number of terms. So n is the number of terms. Here we want to find the value of the 25th term. So we have 25 terms because we started the first term. So n is the number of terms. So it says u sub n equals u sub 1. U sub 1 is the first term, so that would be 100 here, times r, and r is the common ratio, which is 1/2 here. So times r to the power of n minus 1. Okay, so this is the formula for finding the nth term of a geometric sequence. Now let's see how we can put this formula to use in questions. So the practice question I have here, it says we have a geometric sequence. It doesn't tell us what the sequence is. All it says is that u sub 1 equals 50 and the common ratio equals 0.97. So find the value of u sub 10 and u sub 15. Okay, so this is the question and this is the information we have. So given this, let's see what we can do. So firstly, we want to find a particular term. So we need to know our formula. The formula is, let's recap, u sub n equals u sub 1 times r to the power of n minus 1. Okay, so given this, we can phrase that, we can say u sub 10 equals u sub 1. So u sub 1 is 50, so 50 times r, which is 0.97, 0.97 times n minus 1. So n is 10, 10 minus 1 would be to the power of 9. And that gives me a value of 38.01. Okay, so this is the value of my u sub 10 term. Now, how would I find the value of the u sub 15th? So I would use the exact same method. I'd do u sub 1, which is 50, times r, which is 0.97, and the only thing that would change is my power. So I'd do n minus 1, which would be 15 minus 1, and that would be 14. So the answer that I get is actually 32.64. And with this, you can see that the values are actually reducing. So the 10th term is 38 point something, and the 15th term is 32 point something. So the values are actually going down. And this makes sense because our ratio is less than 1. So our ratio is less than 1, which means we're multiplying it and we're getting a value that is less than the original. Okay, so let's look at another example problem. This question, it says, find the number of terms if, find the number of terms, so find n, given that u sub 1 equals 3, u sub n equals 384, and r equals 6 over 3. Okay, so this is the information that we have. So given this, we want to find out what the value of n is. Okay, so to solve this, again, we need to make use of our formula, and that is u sub n equals u sub 1 times r to the power of n minus 1. Okay, so now we have a different scenario here. Here we know what u sub n is, we know what u sub 1 is, we know what r is, so we want to try and find what n is. So to do that, we're again going to just plug in whatever we have into the formula, and that is going to be, let's see, so u sub n, that's going to be 384 equals u sub 1, which is 3, and the r, you might be tempted to just put down 6 times 3, but notice that 6 times 3 is nothing but 2, because 3 2s are 6. Okay, so we have that, and that would be 3 times 2 to the power of n minus 1. Now if I divide both sides by 3, I get 128 to be equal to 2 to the power of n minus 1. Okay, and I just like having my powers on the left side, so I'm just going to erase this. Sorry. I'm just going to get rid of this, and I'm going to actually put it on the other side, just to make things a little more easier. Okay, so that equals 128. Now, if I take, if I do log now, I know that log base 2 of 128. So that's why I like writing this on the right. It makes it a little more easier for me to see this. Equals n minus 1. So log base 2 of 128 gives 7, so that would be 7 equals n minus 1. And when I add 1 to both sides, I get n equals 8. Okay, so this is the final answer that we're looking for. Thank you.